Look up at the night sky, and you might spot a bright, reddish star in the constellation Orion. That's Betelgeuse, a red supergiant nearing the final stages of its life. Its destiny? To become a supernova, an explosive death that will light up our skies like nothing seen in generations. This colossal blast could outshine an entire galaxy for weeks, and when it happens, it will leave behind either a neutron star or a black hole, depending on how the core collapses. The story of Betelgeuse taps into our deep-rooted fascination with how stars live, die, and shape the universe. Classified as a red supergiant, Betelgeuse is in the late phase of stellar evolution. It's vastly larger and more massive than our Sun, so large, in fact, that if it replaced the Sun in our solar system, its outer layers would extend beyond Mars, possibly reaching all the way to Jupiter. Its reddish hue signals a cooler surface temperature, making it one of the most recognizable stars in the night sky. Known to humanity for centuries, Betelgeuse has appeared in mythology, astronomy, and cultural traditions across the globe. Its brightness and distinct color have made it a favorite of stargazers throughout history. Today, modern astronomers continue to observe it closely, using advanced telescopes to unravel the mysteries of massive stars. In recent years, Betelgeuse stunned scientists by dimming dramatically, an event quickly dubbed the Great Dimming. The drop in brightness was so significant, it was visible to the naked eye. Speculation ran wild. Was it on the verge of exploding? Was something blocking its light? Some suspected a massive dust cloud, others a shift in the star's surface temperature. Eventually, astronomers concluded it was a combination of both. Betelgeuse had ejected material, which formed a dust cloud, while a cooler region developed on its surface. These findings gave us new insights into the instability of red supergiants. A supernova marks the final act of a massive star's life. It's one of the universe's most powerful and violent events, releasing incredible energy, reshaping nearby space, and seeding the cosmos with heavy elements. Imagine a single star shining brighter than an entire galaxy. That's the kind of spectacle a supernova can create. For Betelgeuse, this process will begin once it exhausts its nuclear fuel. The core will collapse in a fraction of a second, triggering a runaway chain reaction. The star's outer layers will be blasted into space in a fiery explosion, while the core itself will shrink down to something incredibly dense. Betelgeuse is expected to undergo a Type II supernova, typical for stars with hydrogen-rich outer envelopes. When it finally goes supernova, the explosion will be visible from Earth, even during the day. Its brightness will dwarf that of most stars in the night sky. But despite the spectacle, the event poses no danger to Earth. Betelgeuse is about 650 light-years away, far enough that its radiation and shockwaves won't affect us. What it will do is flood our planet with neutrinos, tiny, nearly massless particles that pass through matter effortlessly, including us. These ghostly particles will arrive before the visible light, offering an early warning to astronomers. The explosion will also produce gravitational waves, ripples in spacetime predicted by Einstein's theory of general relativity. This rare nearby supernova offers a once-in-a-lifetime chance to study such phenomena in real time, across multiple wavelengths and detectors: optical, radio, X-ray, neutrino, and gravitational. What happens after the blast depends on the mass of Betelgeuse's core. If it's under about 3 times the mass of the Sun, it will become a neutron star, a city-sized object packed with unimaginable density. Picture all the mass of the Sun squeezed into a sphere just 20 kilometers wide. If the core is any heavier, it will collapse further into a black hole, where gravity is so intense not even light can escape. Either way, the leftover remnant will become a key target for astronomers, helping us understand extreme physics and the limits of matter. Betelgeuse's inevitable demise reminds us that the universe is always changing. Stars are born, live, and die in a grand cycle that gives rise to new generations of stars and planets. When Betelgeuse explodes, it will scatter newly formed heavy elements, like iron, gold, and uranium, into space. These elements are the building blocks of planets, oceans, and life itself. In time, they may seed the birth of new stars, continuing the cosmic cycle. Studying supernovae like this helps us understand how galaxies evolve, how matter is recycled across the universe, and how life itself becomes possible. It also deepens our grasp of the expansion of the universe. Certain types of supernovae serve as standard candles, measuring sticks that allow us to chart cosmic distances and study the mysterious force known as dark energy. Betelgeuse's expected supernova isn't just a stunning visual event. It's a chance to witness stellar transformation up close, to connect with cosmic processes billions of years in the making. Every flicker of light, every shockwave, every neutrino tells part of the story of how our universe changes and evolves. So the next time you gaze at Orion's shoulder and see that glowing red star, remember, you're looking at a ticking cosmic clock. One day, Betelgeuse will explode. And when it does, the skies will light up with a brightness that dwarfs all the stars around it, marking the end of one star's life, and the beginning of something new. This is Discovery at 2.0. Stay curious.